In this video, we're going to talk about the heuristics people use when they make decisions and when they form judgments about uncertain values. When people form judgments about uncertain values, they rely on the use of some common heuristics according to research that include experts and laypersons alike. Knowing about these shortcuts and their pitfalls is the first and most important step in avoiding them. Elicitation processes that avoid reversion to these heuristics, or that at least minimize their impact, are better than those that do not. Mark Twain said, "It ain't what you don't know that gets you into trouble, it's what you know for sure that just ain't so." Overconfidence is one of the most pervasive problems you will face in expert elicitation. Availability is another common problem you'll encounter in expert elicitation. Ask these people the probability of a flood this year, and they will underestimate it. Ask these people the probability of a flood this year, and they will overestimate it. Availability means estimates of uncertain quantities are driven by the ease with which previously similar events or instances can be recalled. We tend to overestimate the probability of events that come to mind easily and underestimate the probability of events that are not so readily recalled. Which 10-coin toss is most likely to occur in a single toss of 10 coins? We tend to expect relationships that hold true in the large to be reflected in the small. But unusual things do happen. People often expect the properties of a population to be manifest in a small sample. We are inclined to think sample data are representative of the population, and we do not understand how the variability in a small sample can be very unrepresentative of the population's true parameters. This is part of a complex heuristic called representativeness. Here's another example. Linda is 31 years old, single, outspoken, and very bright. She majored in civil engineering. As a student, she was deeply interested in flood problems, dam safety, and saving lives. As a student, she did an internship with the U.S. Army Corps of Engineers and loved it. She got glowing reviews from the U.S. Army Corps of Engineers. Which of the following is most likely? Linda is an engineer, or Linda is an engineer and a Corps employee. Many people would say that Linda is an engineer and a Corps employee. This is the conjunction fallacy. She sounds so much like a U.S. Army Corps of Engineers employee that we overestimate the probability of that event by ignoring the much greater probability of the base rate condition. Here is the probability Linda is an engineer. Here is a probability that Linda is a U.S. Army Corps of Engineers employee. And the probability that Linda is both an engineer and a U.S. Army Corps of Engineers employee is much smaller than either of the two. 90% of all levees that breach have a seepage problem. What is the probability a levee with a seepage problem will breach? People confuse conditional probabilities with their inverse. In the table below, the probability of seepage given a breach is 180 over 200, or 90%. The flip of that is the probability of breach given seepage, and that is 180 over 540, which is 33.3%, a big difference. People tend to confuse a probability with its inverse. The probability of a breach given seepage is not the same as the probability of seepage given a breach. And this is important. Most people who have a medical condition will test positive for it. But testing positive for a medical condition does not mean you have it. They are different events. Base rate neglect is another example of the representativeness bias. Suppose the U.S. population is 300 million and that the number of terrorists in the United States is about 3,000. Now imagine a new technology that monitors all communications, and within 3 words it can detect a terrorist with 99% accuracy. So the probability of a true positive identification is 99%. The probability of a false positive identification, saying someone is a terrorist when they're not, is 1%. Imagine that this technology automatically identifies the FBI. When the FBI gets a report from this system, what's the probability it has a real terrorist? The solution to the representativeness bias is usually to do the math. So let's do the math on this one. 99% times 3,000 equals 2,970 correctly identified terrorists. This is the true positive. 1% of everybody else equals 2,999,970 incorrectly identified non-terrorists. This is the false positive. 2,970 divided by the total is 0.1%. So the probability that we have correctly identified a terrorist is 0.1%. That high detection rate of terrorists fools us. If we ignore the base rates, we get bad estimates of probabilities. A lock with 10-year-old gates malfunctions on 1% of all lockages. An estimate of malfunction frequency is needed for a lock with 20-year-old gates and the same lock design. Because the lock is twice as old, is it reasonable to estimate the frequency of malfunction as twice as often, or 2%? Think of all the things that could be different between 2 locks besides the age of the lock gates. Weather, traffic volumes, accident history, frequency of operation, cause of stalls, and so on are all factors that could affect malfunction rates. There are far more things that is confounding variables than age to consider when estimating malfunction rates. When trying to predict one value based on other values known to be related, we rarely give sufficient consideration to confounding variables. Real quick, how far is it from Baltimore, Maryland to Mobile, Alabama? Did a number pop into your head? If so, that number is your anchor. Another way to arrive at an anchor is for someone to anchor you. Is Baltimore more or less than 691 miles from Mobile? I do not expect you to be able to guess such a quantity precisely, so give me the minimum mileage it could be and the maximum mileage it could be so that you are 90% sure you have estimated correctly. Make the interval as narrow as you can. The answer is 1,012 miles. Did your interval include it? If your anchor was good and you made a sufficient adjustment, you captured the true value. Unfortunately, our anchors aren't always good, and even when they are, we do not make a big enough adjustment. This is the anchor and adjust heuristic. We arrive at or are given an anchor, then we add something to it and subtract something from it. Rarely enough, though. Motivational bias is another heuristic. He knows how he wants this to turn out. Confirmation bias is another problem. Politicians are masters at exploiting confirmation bias. They can cherry pick the facts to convince a willing audience that the other side is full of demons and the other party has done nothing right since they took office. And they'll tell you why. The way a problem is framed or a choice is posed can profoundly influence the choices we make and the answers we give. Which ground beef would you buy? There's a great deal of good information on the heuristics available on the internet. Make sure you pay particular attention to methods for offsetting these heuristics when you read your text.